Hey guys, welcome back. Well, we got this motor all took apart. We actually mostly got it apart this time. Had a little bit better luck. I still can't get the actual rotor out. I don't know, it's just kind of, if I hammered enough, maybe it would come apart, but I don't need it apart right now. I don't think. So here's the update. It was leaking water, and I was right. It was leaking inside the spindle. Now, luckily, it wasn't leaking very much, but it was leaking. I've already kind of cleaned it up, but there were some traces of antifreeze coolant inside of this thing. You can kind of still tell it looks kind of shiny and wet in there. But yeah, it was leaking. I found the culprit. So this part bolts onto this face right here, and there's an O-ring that goes there, and there's one that goes here. And I already took that one out. But look at this one. I'll get you a zoom in. Look at that cut O-ring. You can see the slice marks, and that is where it was leaking. You can see the slices are on the outside, and that's why most of the water was coming out of the outside, but it was coming on the inside too. So if you look, see all this water around that diameter? Even if I look in like the middle right there, there's still traces of water. And if I come way over here like 180 degrees away, it's everywhere. This thing was leaking. Water was somehow, once it got to like say the edge here, it went under this metal and then up this diameter and got into the bearings. Let's see if we can see anything in here. It mostly looks like grease in there. But yeah, it did have water, and we did find a cut O-ring, and I figured out how to take it apart. So this is all good. This is we should be able to fix this now. Luckily, I do have this size O-ring, because if you look over here, that green one, this is the top of the motor. This has O-ring grooves as well, here and here. And last time I took it apart, one of these was damaged, so I changed it, and I do have a little assortment. I'll tell you that, guys. If you ever work on stuff, you can pick these assortments up for like 10 bucks on Amazon, and it comes with a whole bunch of different sizes. You can see this picture, and it sure comes in handy. This just saved me a trip to the store, so it's worth it. Anyway, yeah, we took this apart. We pulled these bearings. I actually popped the shield off of one of these and inspected, and they actually look pretty good. They are ceramic ball bearings. I've always been skeptical about what bearings this thing actually had in it, but it does have angular contact. At least it's written on them, they're P4 accuracy or precision, and then ceramic balls. So anyway, we're not even going to change these bearings. I do have spares, but I'm going to save that for a later date, because right now we've been using this jig rigged up thing to spin it, and this vibrates. And I got to redo this and get it made. Maybe I'll take the measurements now that it's off. Yeah, I should do that. But I don't want to put brand new bearings in it until I remake this, because this thing's vibrating and it's just going to tear up bearings anyway over time. So for now, we're going to get this, we're going to finish cleaning all of this. We're going to get new O-rings, put those on, reassemble this thing, get it back on the machine, get it running, and let the coolant run for a while and see if we have any more leaks. And hopefully we don't. I might even take an air gun and kind of put some pressure, because this thing's got some weird, like, here's a hole, like, I don't even know where that goes. Might actually do a little investigating, see if I can figure this thing out. But anyway, it's going good. We're going to try to get this thing all put back together tonight. Alright, so we got our new O-rings in. As you can see, they're not the same color because my assortment didn't quite get small enough. So I had to, luckily I kind of got lucky, the local auto parts store was still open, and they actually had these, which funny, their assortment was out, but the lady named Stacy that works there was nice enough that she went back and looked again and found some more. So shout out to O'Reilly Auto Parts. But yeah, we got these new O-rings, popped them both in. Here's the old two that we're replacing. You can see both of these have damage. Let me see if I can get a little clarity on the situation. Yeah, you can see cut marks, scratch marks. These were definitely needed to be replaced. So that's cool. That explains why we saw coolant. We cleaned all this up pretty nicely. Dried out, as you know, looks pretty good now. This little thing here is for like electrical isolation, but we're gonna just let that be. So yeah, about to begin reassembly. Well, we got it all put back together, and admittedly we only ran it for about 30 seconds, but so far no leaks. So I guess we won't know for sure till we get at least an hour on it probably. But we've had the pump running for about 20 minutes. This seam is where it leaked before, and it looks dry, which it should be. We did find damaged O-rings. We replaced them. We found some other stuff. So this spindle, we always had bearing issues with it. That's why we decided to turn it into a motor and drive this spindle with that motor. And I finally managed to get this thing about 80% of the way apart. I never got the rotor out, but I got pretty much everything else apart. That and the upper bearing couldn't come out. But anyway, I don't think they actually put this together correctly. I found, I don't think they had the preload. This thing's spring-loaded, and I don't think they actually had it tightened all the way. And that might have been one of the reasons that this thing would screw up so much. Doesn't matter now because it's just a motor, but yeah, that's, you know, I guess that's China for you. Buy something and they don't even put their own products together correctly. But anyway, we got it put together. I think the leak's going to be fixed. We'll run it some more tomorrow and verify, but I think it's fixed. So that's cool. Making progress. I'm not even sure what the plan is right now. I think the machine's almost ready to cut. We need to get this oil or final installed. You can see it's just zip tied on there right now. So we got to find a resting place for that and a bracket and whatever to clean that up. And then we got to do the electronics side of it. So let me show you what we're going to do there. Okay, so in the interest of keeping this simple, this is what we're going to run. So on the bottom, we got a Amazon cheapy Arduino, which these used to be 10 bucks, now they're like 15 bucks. And then on top of the Arduino, we got a relay shield plugged in. And I forget, that was like 10 or 20 bucks. Wasn't too expensive. There's no way I got more than $40 in everything in this picture. And all we did, what we want this to do is we want a computer that oils the spindle automatically, so I don't have to think about it. In fact, when I was machining yesterday, I did all these test cuts, and I forgot to oil the spindle the entire time. Because that's just not something I normally do, and I don't want my memory to result in these bearings failing. So we're going to set this up to be automatic. So anyway, all we did to keep it simple, we grabbed the blink code. So on Arduino, they have libraries and example codes and things like that. And one of them is called blink, and it's just 4 lines of code. It basically just turns a pin to high, waits a certain amount of time, sets the pin low, and then waits a certain amount of time. So what we did, we set this up to turn on relay number 1, which is this one. So right now this relay turns on for 4 seconds, and then it turns off for 4 minutes and 56 seconds. So that works out for a total of 5 minutes. So every 5 minutes, you'll get 4 seconds worth of air blast. And from our testing, that should be plenty. When you turn this thing on, usually within at least a half a second to a second, you've got an oil mist coming out. So we should get a good 3 seconds of air, oil, mist feeding the bearings every 5 minutes. And frankly, that's probably way over oiling it, but I mean, who cares? I bought a gallon of this stuff. I'll show you what I bought real quick. This was 30, 40 bucks, but it's this Mobile Velocite oil number 6. So you can see it's ISO 10, so that's a 10 weight oil. And actually it should probably be a 20 weight. I didn't know it at the time, I just guessed and said, it's probably close, and bought it. And then I went and actually, I can show you guys, but I actually found an equation, or a couple equations you can use to approximate the viscosity you need based on bearing diameter, bearing temperatures, and once you basically you figure out the kinematic viscosity, and then that's, you know, at temperature. So you have to guess at the temperature, figure out the kinematic viscosity you need, and then adjust it for the actual viscosity at room temp, which is how these are rated, at like 40 C or something. So anyway, we did all that, and it came up that we needed a 20 weight. So if anything, a 10 weight's too thin. We probably should have got a 20 or a 28 or a 32 or whatever. But hey, we're going to run this for now. If the bearings fail, I'll change them and get some heavier oil. But I'm getting ready to start cutting, so tomorrow we are going to come in here. I did order some fittings. I can't even remember if they come in tomorrow, but the one thing we were missing, let's see if I can find it. We had an air solenoid. Yeah, I don't know where, here it is. So this solenoid is 1/8 NPT on either end. You can see we had all these adapters and junk. So I ordered the proper fitting that'll screw right into this and have a 1/4 inch hose barb. So we got those 2 fittings ordered. They'll be here tomorrow. I think tomorrow. And then we just got to take some hose clamps and basically just cut this hose and stick that solenoid in line and put the hose clamps on. And that's pretty much the plumbing for the solenoid. And then we got to electrically run 2 wires probably to the back of the machine, and then mount our Arduino somewhere, set it up on some kind of power supply, which I forgot to buy. But anyway, it's not too far from working. We'll probably be able to get that going tomorrow. So, and that's the plan. Now that the spindle motor is presumed fixed, I think it'll be fixed, we are starting to run out of things to fix on this machine. Once we're going to try to get that oiling system wrapped up tomorrow. Hopefully we'll accomplish that. And at that point, really the only thing I can think of, that piece that goes here, which is this, it's literally just a bolt, a nut, and some washers with a pulley in the middle. But this isn't perfectly centered. It definitely vibrates. We actually powered this up without the piece on, and it's smooth as could be, or pretty damn smooth. So it's no secret we know that's out of balance. So we'll maybe tomorrow we'll take some measurements before we put it back on there, so I can try to get a proper part machined to reduce the vibration. Yeah, this thing's coming together. With any luck, if we work on this tomorrow, then the next day, hopefully we can actually make a couple of parts, because at the end of the day, that's what this machine's for. And we've done some test cuts, and the test cuts are looking fairly promising. They're not perfect, but it looks promising. But what we need to do is actually build a couple of parts and see how that goes. So that'll be the plan in the next couple days. All right, y'all, I appreciate you guys checking this out, and y'all take it easy.